Help, my head is spinning, and here you are grinning? Now my head's splitting, the pain's not quitting.
Take a pill. And chill. The unassuming compound that in Panadol is found is acetaminophen, which when taken now and then helps you keep the pain at bay, makes the pounding go away.
The pill is great, I must admit.
See this groove over here? Name it.
I'll go with the amide combo. That's C doubly bonded to O, while singly to N. I've made my choice then. A store, what a draw, let's step inside. Sensational gardenia amide. When's a group called amide? It's about time we decide. If we spot C, O and N, then most certainly that's when you need a break. Oh no, toothache?
How to make it wane, this terrible pain.
The electric daisy, or toothache plant, whoopsie, is a natural remedy. It numbs the pain tremendously. Thanks to spellanthal in the daisy, you no longer have to go crazy. Spellanthal is an amide, it can't be denied. Atoms C and O, though a great duo, well, just won't cut it. The amide outfit must include N, but only then will they really jam and groove, in a way that you'll approve.
IR 3535, and propanol. Contrive to banish any unwelcome guest. This presumably is for the best.
Well okay, but what's the scoop?
Found in both is the amide group. N and O once joined to C, are called amide, let's agree. Cocamide MEA, an amide by the way, is such a swell component in dishwashing detergent. It is bubbly, sudsy and perky, simply the life of the party. When C is linked to N and O, we get the amide group, you know.
Asparagus with egg and milk, Mayan chocolate smooth as silk, served in a cup, coming right up. Ingredients for a Mayan chocolate drink: chili pepper, chocolate, and water. I think this drink's so mean, it makes you keen. Chili peppers, capsaicin stings, such tremendous pain this amide brings. But chin up, for on the upside
there's chocolates and andamide, which reputedly generates just blissful and euphoric states.
We get amide when C, O, and N are united.
These three are having a ball and all are invited.
Within this asparagus so green, is undoubtedly asparagine.
The egg nutrient vitamin B5 boosts our power, enables us to thrive.
The amide group is found clearly in each compound.
So what is the amide combo? It's C doubly bonded to O, while singly to N, that settles it then.
Amides are used widely as colors in crayons, pencil, and ink, and paper industries.
Leia here from LeiaFirstSide.com, and in this video I will show you how to name amides. An amide is a molecule that has a carbonyl or carbon double bound to an oxygen attached to a nitrogen group such as an H2. Don't confuse the amide with a carbonyl bound to an OH, which is a carboxylic acid, or a molecule that has a nitrogen bound to the R group without a carbonyl, which is simply an amine. The amide functional group is a carboxylic acid derivative. That means if you start with a carboxyl, remove the OH, and simply replace it by something like NH2 or NR2, you get your amide. When naming amides, you simply drop the oic acid from the carboxyl naming and replace it with the suffix amide. We'll start with this simple example by identifying and highlighting the parent chain. The amide is understood to be a primary functional group, which means it shows up in the beginning of the molecule and gets the number 1. I have 2 carbons in my parent chain for a first name of F, only single bonds gives me a last name of ane, and the carbonyl bound to the NH2 gives me the suffix amide. I don't include the number because it's understood to be number 1, and since amide starts with a vowel, I drop the e and ane for a final name of ethanamide. When you have a substituted amide, you treat it the same way and break it down using my puzzle piece approach. We first identify and highlight the parent chain and number so that the amide gets your number 1. Having 4 carbons gives you a first name of bute, and only single bonds gives you a last name of ane. We have a 1-carbon substituent on number 3, which gives me the prefix 3-methyl, and the carbonyl bound to nitrogen gives me the suffix amide. Drop the e in ane for a final name of 3-methyl butanamide. When this substituent occurs on the nitrogen rather than the parent chain, you treat it the same way, but instead of having a number preceding your substituent, you have the letter N. For this molecule, we have a total of 5 carbons, which gives me a first name of pent. Only single bonds gives me a last name of ane. Carbonyl bound to a nitrogen gives me the suffix amide, and a 1-carbon group attached to the nitrogen gives me the prefix N-methyl. I drop the e in ane for a final name of N-methyl pentanamide. When you have multiple substituents off your nitrogen, you treat it the same way. Just be sure to include the appropriate prefix. For this molecule, we have a total of 3 carbons in the parent chain for a first name of prop. Only single bonds gives me a last name of ane. The carbonyl bound to nitrogen functional group gives me the ending amide. Since I have 2 methyl groups coming off of the N, I add the prefix N, N dimethyl to show that both methyl groups come off the N and di because I have 2. I drop the e in ane for a final name of NN-dimethyl propanamide. Notice that we have a comma between the 2 N's and a dash between the N and the name, and that's because even though the letter N is not a number, we treat it as if it's a number to show where the substituents are attached. So think of this as the number N rather than the letter N. In this example, we have a methyl group coming off the parent chain and off the functional group. We start by highlighting and identifying the parent chain, and get a total of 6 carbons for a first name of hex. Only single bonds in the parent chain gives me a last name of ane, and the carbonyl bound to N functional group gives me a suffix of amide. I have 2 methyl substituents, one coming off the nitrogen and one coming off the carbon chain, and so I include the prefix 5, N dimethyl. This is to show that I have 1 methyl group on the parent chain and 1 methyl group on the amide substituent. Numbers always precede letters, and that's why you have the 5 followed by the N. You drop the e in ane for a final name of 5N-dimethyl hexanamide. When you have more than one amide, you treat it the same way, but simply include the prefix di before the functional group to show that you have 2. Since this is a symmetrical molecule, I can number from the right or the left. I have a total of 8 carbons for a first name of oct, and only single bonds in the parent chain for a last name of ane. Given that the amide is a terminal functional group, if we have 2 on the molecule, we assume it shows up on the first and last carbon, and so both numbers can be omitted. And so we add the suffix diamide, simply indicating that we have 2 amides on this molecule. Putting the pieces together, we get a final name of octane diamide, omitting numbers for the functional groups, and also keeping the e in ane because the consonant d in di separates between the 2 vowels. We'll end with an interesting example. At first glance, we appear to have a symmetrical molecule. However, on the right we have a carbonyl next to the NH2, but on the left we only have an NH2. The parent chain for this molecule contains a total of 5 carbons, where the amide is higher priority and therefore gets the lower number. A total of 5 carbons gives me a first name of pent, only single bonds gives me a last name of ane, a carbonyl bound to an NH2 on the first carbon gives me the suffix amide. The NH2 group, or the amine, is not the highest priority here, and so in place of the suffix amine, we demote it from functional group down to substituent with a prefix of 5-amino. We drop the e in ane for a final name of 5-amino pentanamide. In upcoming videos, I will show you how to name aromatic compounds.